Hi everyone. Let's talk about fuses today. These have been around a long time and they're needed to protect electrical circuits. In most commercial and residential environments, we now have a circuit breaker, which is doing the same function as a fuse, except it's resettable. And the purpose is to prevent too much current from traveling down an electrical circuit, which could cause a fire. So a normal fuse like this is simply a really small piece of wire in a glass tube, and it's calibrated such that this is the weakest link in the circuit. So before your wiring will melt where it really matters, where it could catch something on fire, this glass, which can withstand the high heat, will allow this wire to melt and break the circuit. It's that simple. And they tune the metal, and the metallurgy and the alloy such that it'll have the desired trip characteristics, which means you want the fuse to blow if something's wrong, but you don't want it to blow if there's nothing wrong. That's a nuisance, called a nuisance trip or a nuisance blow. And in Tesla cars, they have the same thing. So when the Model S came on the scene, they were putting these things in. This is the same thing. It's a ceramic body that can withstand high heat, and inside you have this ceramic housing, and this one blue. So there's these little copper pieces that have really thin cutouts on them. So kind of like a dotted line, like you would tear a piece of paper. And there's a whole cage of these things in there that would connect to the other plate. And then you can see this is full of sand, and some of the sand is hard now. It actually turns into glass. So the reason they do this is when the fuse blows and it breaks a high current electrical circuit that has inductance in it. And inductance is the property of electricity to continue going. It's like the electrical inertia. So the circuit in the car has inductance. So when the fuse melts and breaks the circuit, the electrons that are stacked up behind here say, I want to keep going. So they'll attempt to jump across this gap. And when they do, that creates a plasma event. The fused metal vaporizes and turns into a superheated gas that's electrically charged. And this gas is conductive, so it will continue to carry high currents, but it's high heat. It's not as efficient as the copper. So it will melt this glass, and when it melts the glass will fuse, run in between the plasma and break the arc. So that's what's required to break a high current circuit. Now the problem Tesla has is they have real high peak powers. So when you have a simple fuse like this, what you have to do is make the wire thick enough so it won't blow when you stomp on it and have 1,000 amps going through the circuit. But if something were to fail, like a transistor in the drive inverter, you want it to open the fuse without causing a fireball in there. So Tesla found this was extremely hard to do as the performance levels kept coming up. Back in the early days of the Model S, when you just had a rear-wheel drive car, you could have this fuse, which was rated at 550 amps. It would withstand the high current pulses long enough to not blow. But if the inverter were to fail or transistor were to fail, the fuse would open and you wouldn't burn the car to the ground. So as they came up with later versions, they came up with all-wheel drive and then insane mode and then ludicrous mode. They found they were having trouble. They switched to a more robust fuse like this. This one's sealed ceramic. It probably has a different kind of sand in it. This one's not blown, so I don't want to dissect it. But basically just improved design. And they still found that sometimes the inverter could fail and the fuse wouldn't open. In some cases, the pack would actually open, like the bond wires between the cells in the pack would do a thing called zippering. One would fail open, and then the rest would be under high stress, so they would fail pretty quickly, and then it would exponentially increase until the pack was completely open. Now, obviously, that destroys the pack. You can't just drop a new fuse in after you replace the bad inverter. So they came up with this really cool thing. So let me give you a bit of a background. on a lot of cars, started with some of the European cars, they had this little gadget. It's called a pyrotechnic switch. And this one's blown. Normally when this is made, this metal would be connected here. And this is set up in the car to break the 12 volt power when a small explosive goes off in here. Basically, there's a little charge, much like you'd find in an airbag initiator, kind of like a, or even in demolition. You fire a current pulse in here, and a hot wire lights a chemical pot. And in this case, there's a gas generator in here that creates high gas pressure and slams this little blade out. You can see there's a really sharp, hard plastic blade, and that blade cuts through this thing and severs the connection. And this is designed to break a moderate amount of current, I think it's got the data sheet over here. Let's see. Yeah, this thing. So I'll link this in the description if you want to look at it more. But these have been used in Volkswagen, BMW, Mercedes for many years to protect the 12 volt circuits. So when you get into an accident and they want to shut off things in the car so that there isn't a fire or other damage, and also to stop other airbags from deploying, this would be blown. So this thing can break up to 400 volts, and it can handle 300 amps of continuous current and peak currents of up to 200 amps. It's basically just limited by the metal here. But the problem is this can't really break an inductive load. If there's a high voltage across here when it breaks, the plasma would just burn this thing to a crisp. It doesn't have sand in it or any way to quench the arc. So Tesla did put these in their cars in the early Model S, and they use this to break the power to the contactors in the pack. The contactors are the main switches or relays that stop high voltage in the pack. And that does work, but sometimes the contactors aren't really happy to break a high current load with inductance behind it. They'll probably break it, but that'll be the end of the life for the contactor. So Tesla came up with a really ingenious thing. Let's see here. Is this the right one? No. So this is what they came up with. So this drops in the same location this fuse does in a Model S or Model X pack. Bolts to the same two terminals. And this one I've already got apart. So what they have in here is this copper area is a current shunt, which means you can see it's a really thick piece of copper, but they've cut out some of it here very carefully. And what they do, when you send high current across here, you get a voltage drop across that. So they added a small circuit board in here, and it's self-powered. It's got its own 2 lithium batteries in here. And these things are probably good for, they're rated for, I think, a 10-year shelf life. So they're at least probably around they'll last at least that long. This is connected to the current shunt, so it's constantly watching the current across here. When it exceeds a certain value, it fires a current pulse into the little squib to detonate one of these things and break the contacts, and that's connected right across here. So that would break, but if that happened, like I said, the inductance would turn this whole thing into a plasma ball. But what they did to overcome that is they put these 2 fuses in. I have one here. These are specially rated to handle really high, excuse my finger, I cut it earlier today. These are rated to handle really high break current, like 30,000, or this one's 50,000 amps of break current at 250 volts DC. And then it's got another rating, 600 volts AC at 1,000 K amps, so 100,000 amps. So this has got special glass in it and special alloy, and it's designed to quench the arc that develops. But these are only like 30 amp fuses. So how's that going to work? So what happens is normally the metal bar that's running through the pyro switch in here carries all the current. But when that trips because there's excess current running across here, then this opens. Now the load, and of course keep in mind that's a fault load. That's a load that should never be seen in normal operation. So these things share the load very briefly, but all the current switches from going here through these two fuses, and of course they fuse, they blow, but these are designed to break an inductive load under really high current, and the glass in there melts and then quenches the arc, stopping the current flow, and that's over very, very fast. The operation time is less than 3 milliseconds on that pyro fuse, and I'm sure these things don't last much longer than that at let's say 2,000 amps fault current. So what they've made is an electronically driven fuse, and by altering the parameters of this circuit that watches that current, they can control exactly how it blows. So they can get no nuisance trips, no problems with over time that metal weakening from successive ludicrous launches, which of course it's going to heat the fuse up each time the conventional thermal fuse will heat up. It's just like bending a paper clip back and forth. Eventually it'll fatigue and blow, after so many romps, and that's a nuisance trip. You don't want that to happen. So this is immune to that because the electronics are watching the current flow. So when this blows, it takes the power from these lithium cells and fires that squib, and then its job is done. After the fault is repaired, this whole module can be replaced. 2 bolts, drops right in, and you're good to go. The only problem with this is this depends on power from these lithium cells to fire that squib. And I didn't look up the data sheet, but if I can find it, I'll put it in the description. Most of these cells are not guaranteed to work much beyond 10 years. So the problem is once these batteries die, you have no protection. So your pack will zipper. It probably won't create a big problem, but the protection goes away basically. So I'm sure the engineers at Tesla realized this was a problem, and they came up with this guy. It looks almost the same. It has the same 2 fuses, the same pyro disconnect, but in the base, if I can get it out, they made this circuit board. Now this circuit board, you'll know, has no battery, and it has this connector is what goes up to fire the squib. There's no external connection here. So this is really genius. What they've done is they've taken a chip made by Analog Devices, and this is an ultra-low voltage step-up converter and power manager. And it's designed to take really low voltages, like 20 millivolts, and use basically a transformer, you can see in this circuit here, to boost the voltage of that really low voltage and power something. In this case, that really low voltage is coming right across the current shunt. The voltage drop across this copper. This may seem like a big hunk of copper, but there's probably, tens or, even hundreds of millivolts across here when there's, several thousand amps flowing across this. So that goes into this transformer, and to cut costs and also size and weight, rather than a conventional transformer that's wound with, coils of wire, like you might find here. This is going to be an upcoming teardown. It's got coils of copper in it and a big bobbin. They made the coils on the printed circuit board. This is called a planar transformer. So the coils run in many layers. This is a really thick circuit board for its size. I don't know if you can tell. It's like 3 millimeters. So traces are in the many layers of this, and that forms the windings of the transformer. And the transformer is able to boost that voltage up to, the 6 volts or so that's needed to fire that squib. And it also powers the current detect circuitry so that they can set a really accurate threshold and have this thing trip exactly when they want. They can dial the exact amperage and even set a curve, so a brief pulse won't trip it, but a pulse over a certain time will. Ingenious. And this is retrofittable. So when a pack comes in that's had a nuisance blow, they can put this in, and this will last forever because it's self-powered. It doesn't need the batteries that the old solution needed. And then the car's protected forever because it's powered by the fault. Pretty genius. Now, that was in production probably in around 2017, I would guess. And then they came out with the Model 3. And they knew going in that they would need this pyro fuse. So rather than, they built a dedicated device. I don't know if this is made by Tesla or for Tesla, but it's a dedicated device for the Model 3. And it works kind of like, this guy, but it's bigger. So this one's blown. So here's where the terminals for the squib are. The explosive lives in there. And this probably looked about like that when it was new. This heavy aluminum bar was, get it out of there. It was connected right here. When that explosion happened in here, the hot gas just blew that apart. And here's the cool part. This would have been in there when it blew. I don't know if you can see. There's a whole bunch of little metal cutouts in here, little shelves. And the force of that gas, of course, as soon as it blows, the inductance is going to try to, keep an arc going across these two pieces of metal. But the force of the gas is going to blow that, from the explosion, is going to blow that hot gas down and into these forks, these metal grates. And that will cool off and isolate the arc. So the plasma no longer is a plasma. Once it cools down, it won't be conductive anymore and extinguishes the arcs. If you take apart a high current breaker, like you would find in your house, like for the air conditioning or something, you'll see a plasma arrestor that looks just like this. So they've built this all into one unit, and rather than have a circuit board that deploys it, the battery management system in the Model 3 has a circuit that watches the current from the same place. Basically, they watch for the battery management system. They have a hardware circuit and probably a software circuit to trip this thing in the event of a current overload. And also, if the car's in an accident, they use this to break the circuit. And it used to be you could buy this for about $15 from Tesla service. Like if you had a relatively minor accident in your Model 3 or Model Y, you could just go buy this and put it in. But Tesla restricted the part. Those of us that were repairing salvage vehicles can no longer easily do so just by buying this proper part that's nice and safe and putting it back in. It's restricted, so now rather than $15, you find the secondary market, like on eBay, selling these things for sometimes as high as $300 that have come out of cars where it didn't blow somehow. Or, unscrupulous people have actually welded this back together and then put a resistor in the end here. So that's a super dangerous condition. Now the car will just heat up that resistor and not break this if there's an overload. So Tesla's restriction is actually making things more dangerous. Don't know why they do it, but they do it. Luckily, like these guys, Autoleave, I think they're a French company. They've started making higher current versions that can handle the inductive load on their website. I'll provide a link. So it may be possible to retrofit one of those into a Model 3 or Model Y in the future, and then safely repair a Tesla. If what I'd love to see happen is right to repair legislation passed at the state or even the federal level that would give us access to repair parts. And in this restricted, it's the same thing Apple does. If you break the glass on your screen, you can't just go buy a new piece of glass and replace it. Apple restricts the parts. So Tesla's doing the same thing. I love Tesla and what they're doing, but stopping people from repairing cars is not a very good thing. It's wasteful. Anyway, I'll stop my rant there. I hope you found this interesting. There's a lot of pieces. Yeah, it smells like kind of gunpowder. It's basically like it is like a small explosion. I don't know if you can see down in there. There's residue from probably not only explosion but the plasma event that pushed that in, and it's got a vent here that's after it goes through the arc arrestor, the hot gas comes around and is able to vent, but they've got a filter in there to stop that from becoming dangerous. Pretty cool. Well, if you have any questions, be sure to leave a comment below. I do try to read them. If you like this, please like the video and subscribe. I'll keep making them as time permits. And also let me know what you'd like to see. This was viewer requested. How does the pyro fuse work? So I did it for you guys. All right. Have a good evening.